Computers make no sense. Throw some metal in a box and boom. What the heck is going on here? Inside your PC is a central processing unit or CPU. It's basically just a piece of silicon with billions of microscopic switches called transistors. Depending on the flow of electricity, they can be on or off, kind of like a light bulb, which gives us two states, 1 and 0. The value at one of these switches is called a bit. One bit by itself doesn't really do much, but put them together and a group of 8 bits is called a byte and can have 256 different combinations of zeros and ones. Congratulations! We can now store information by counting in a system called binary. Okay, now that we can store numbers, we just need the computers to actually, do something with them. Using transistors, you can make logic gates, which are electronic circuits that encapsulate logical statements. You can think of it as a light bulb with two switches, where the light only turns on under certain conditions, for example only if A and B are on. By combining logic gates in a clever way, you can build circuits that perform calculations according to Boolean algebra, which is a system formalizing mathematical operations in binary. But even though computers understand zeros and ones, for humans it's not really all that useful. So, using a character encoding like ASCII, we can assign a binary number to each character. When you type an A on your keyboard, it gets translated into this binary code, and as soon as the computer sees this, it says, "Ah yes, that is a capital A," and slaps it on the screen. How these devices fit together is handled by an operating system kernel, like Windows, Linux, or Mac, which sits between computer hardware and applications and manages how they all work together, for example with device drivers. Input devices allow you to give the computer instructions with the press of a button, but at the lowest level, computers only understand instructions in machine code, which is binary code telling the CPU what to do and which data to use. When it comes to following these instructions, the CPU is kind of like a genius, just with the memory of a demented goldfish. It can handle any instructions, but it cannot store any data, so it's only really useful with random access memory or RAM. You can imagine it like a grid, where every box can hold 1 byte of information, which can be data or instructions, and has an address so the CPU can access it in 4 steps. Fetch from memory, decode instructions and data, and finally execute and store the result. This is one machine cycle. Since a program is basically just a list of instructions in memory, to run it, the CPU executes them one by one in machine cycles until it's complete. Oh yeah, did I mention that this happens really fast? Modern CPUs can do billions of cycles every second, which are coordinated and synchronized by a clock generator. The speed of this clock is measured in gigahertz, and people often overclock their CPUs to improve performance, which is nice but might just set your PC on fire. What's even crazier though is that a CPU has multiple cores, which can all execute different instructions in parallel, so at the same time. Each core can also be split into multiple threads, which allows every single core to handle multiple instructions concurrently, so switch between them really quickly. Okay, that's cool, but it doesn't matter how powerful a computer is if you have no way to give it instructions in the first place. Typing machine code by hand would probably make you go insane, but luckily, you don't have to. The kernel is wrapped in a shell, which is just a program that exposes the kernel to the user, allowing for simple instructions in a